Let's jump right into this question and see what the story is with this question. All right, cool. So the question reads as follows. The first four terms of a quadratic sequence are 13, x, 29, x plus 24, and so on and so on. So we are required here to calculate the value of x. Now, what you need to understand is when you're working with sequences and series as a matriculant, remember, there's always three patterns that you have to know and master. You need to know a linear pattern, which is also known as an arithmetic pattern. You need to know a quadratic pattern, and you also need to know how to work with what we call a geometric pattern. You need to know what is the difference between these three patterns, because if you don't know what the difference is, you won't be able to understand which are the relevant formulae for working with this particular pattern, or how do you actually try to find maybe the general term or subsequent term in that particular pattern. So in this case, we are told that it is a quadratic pattern. So what I'm going to be doing, I'm going to think about it in the context of what do we normally do when you are working with a quadratic pattern, right? So let's see what the story is here. We were told that it's quadratic, right? And we know for a fact that a quadratic pattern is unique in the sense that it has what we call a second common difference. If you ask me, I wouldn't be happy if you said a quadratic pattern or an arithmetic pattern has a common difference. This one has a second common difference, right? Now, how does it look geometrically? It looks like this. You normally have a term here that you are looking at, and then you would have another term here, which is the second term. You would have a third term, and then you will have a fourth term, and then this pattern goes on and on, right? But we know for a fact that the difference between these two terms are going to give you some number here, right? And then the difference between this guy and that guy is also going to produce another difference between term 2 and term 3. And then the difference between this term and the next one also produces a particular term that we are going to also put here. But the beauty about a quadratic pattern emerges in this following line, in the sense that the second difference, the last part there, whatever I'm going to get here on the third step, this difference here, which is the second time that I'm trying to find the difference between subsequent terms, this part has to be always the same. This is what is unique about a quadratic pattern. This is what makes a particular pattern to be quadratic. If a pattern doesn't give you the first difference, but when you go on and try to look for the second difference, you get something constant, something that looks the same, then you know for a fact that particular pattern is a quadratic pattern. Now, since we were told in this question that we are dealing with a quadratic pattern, we should expect it to behave like this. This is how it needs to behave. We're going to find the first difference, and then we're going to find the second difference. But the beauty is the second difference needs to be the same, because this is a quadratic pattern. Right. Now, let's see what are the entries for this particular question. We were told that the first pattern, the first term is 13. We were also told that the next term is x. We know that the next term is 29, and we know that the next term is x plus 24. Right. These are the terms of the original pattern. Now, when we do subtraction, we do reverse subtraction. It's always in reverse. You take the second term, you subtract the first term. We don't always do term 1 minus term 2. That will be the wrong order. The subtraction is always in reverse. That's how you actually work your subtraction. So what I'm going to get here is going to be x subtracting 13. And I don't know the value of x, so this is going to just come down as x minus 13. And then the next one is going to be 29 subtract x. Again, like I said, we do reverse subtraction. So it's term 3 minus term 2. And then on this one is going to be x plus 24 subtracting 29. That should give us x minus, because 24 minus 29 will just simply give you 5. That is the first difference. Now we have to continue with our reverse subtraction again to try and find the second difference. So we are going to be looking at 29 minus x, which is the term that we have here. Subtract the term before that, which is simply going to be x minus 13. But that needs to be the same as the difference between x minus 5, right, as well as 29 minus x, right? So this is what makes a quadratic pattern unique. The last parts need to always be the same. So then I've got one variable with one equation, then I know for a fact that I can be able to find the solution to this. So I'm going to just say, okay, 29 subtract x, right, minus, if you subtract x there, you'll have minus x. If you subtract negative 13, you're going to have positive 13 is equal to, then you have x minus 5. Then you subtract 29, you're going to have minus 29. Then you subtract negative x, you're going to have positive x. Now, it is very important for you to always make sure that when you are doing these subtractions, particularly in this context because you're dealing with multiple terms, a binomial, for example, minusing another binomial, always use a parenthesis, always use a bracket. Because if you don't use brackets, you will not subtract correctly. That's a mistake that a lot of of you guys do, because you don't subtract the previous term in brackets. Always make sure you use brackets when you are subtracting. Okay, cool. So let's see what is going to happen now. What I'm going to do from here is just basic mathematics we've been doing for a very, very long time. So the sum of 29, if you look there, we can actually add 29 and 13. When we add 29 and 13, we are going to get a 2 there, because 9 plus 3 is 12. 2, 3 is going to be 42, right? 2, 3, yes, going to be 42. And then minus x is going to give us minus 2x. And then on the right-hand side, I've got x as well as x. Those are what we call like terms. It's going to give us a positive 2x. And then minus 29 minus 5 will simply give us minus 34, if we are not mistaken. Yes, it's absolutely correct. Now, after this, I'm going to simply do what we call witchcraft mathematics, which is as good as saying you take one variable to the other side, one term to the other side to join the friend, because this guy is friends with that guy. So it is as good as saying we are adding 2x on both sides. If I add 2x on this side, I need to also add 2x on this side in order to balance the equation. What you do on the left, you also need to do on the right-hand side. Remember, in science, they always say they've got the law of conservation of anything. We also have the law of conservation of mathematics, which says what you do on the left, you need to repeat on the right-hand side. So I'm going to have 42 here, and then I will have 2x plus 2x, which is just going to give me 4x. Once more, I'm not happy with this 34 here, so I'm going to try and add 34 on both sides. What you do on this side, we also need to do on the other side. When you add 34 and 34, this is going to disappear, but when you add 34 on 42, we are just going to have 42 plus 34. Right, beautiful stuff. Then this actually amounts to 4x equals to, there's a 6 as well as a 7. So you're looking at 76 equals to 4x. All right, now we need to continue with what you're looking at here. You will notice that once you've got 4x is equal to 76, you can divide both sides by 7. Your final answer is going to come as 2 as well as 4. So your x value will just simply be 24. It's just as simple as that. When you divide both sides by 4, you're going to get that x is exactly equal to 24.